All right, so I turned on the video. I called up the long division homework that was due tonight, but I moved it back a little bit till Wednesday because we're really still talking about stuff in this homework. But I wanted to look at just as a refresher for things that we did last week. I wanted to look at just a couple of the problems here. But if you have questions about some of these problems, then feel free to ask them. I was going to skip down to a little bit later in the homework. But let's start with just as a reminder of long division, let's start with number 6, I think it is. So this says use synthetic division. So the abbreviated version of long division, right? Synthetic division, and the remainder theorem to evaluate P of C, where in this case C is -2, right? So for that polynomial, 4x to the 5th, etc., we want to figure out what P of -2 is. Of course, we could do that just by substitution, right? Plugging -2 in for x into that expression. And that would take us a little while to evaluate that, to simplify and evaluate that, right? But remember, we can also use synthetic division with this divisor of -2, right? And that also will give us the value for P of -2, right? Because when you do synthetic division, and right, you're going to get possibly a remainder from that synthetic division, and whatever that remainder is will be the value of the polynomial at the given divisor. Okay. All right. So that was a kind of a thumbnail review of what we did last week. Let's try it though. So you write this down for me, so because I got to switch off to some paper here so I can write. So write that down to remind me what the polynomial is. Let me scroll down here if I can far enough so that we can get some blank paper here, so that we can do this. And so remember, synthetic division, right, is pretty gonna have to create some paper there. Synthetic division, right, is pretty easy if you've once you've practiced it a couple of times. So on a test, for instance, on test number 3, which is coming up a week from Wednesday, right? Not this Wednesday, but the following Wednesday. If you practice that a little bit, then those problems on test number 3 you should do pretty well on. That should be one of the easier things in test number 3, right? So remember, we want to use this divisor of -2, correct? And so so we write that down. You really don't have to separate it here, but I just am in the habit of doing that. So I write the sort of separation bars here, and then you write down the coefficients for the polynomial, right? Be sure you include 0 coefficients for missing terms. So that polynomial was, oops, let's write that down so we remember what we're doing here. So that polynomial was, what was that? Okay, so what was P of x in this problem? Something x to the 5th, what? Can you write that down for me? 4x to the 5th, what?
Plus 10x to the 3.
Plus 10x cubed, right? And then keep going.
Plus x and x
plus x and plus 1. Okay, all right. So there's the polynomial. So this is a pretty high degree polynomial, right? 5th degree, right? This is 5th degree. The leading coefficient is 4. By the way, just as a reminder of polynomial terminology, right? So the degree here is 5. We often denote degree by n when we're working with polynomials. So you might put n equal 5, or of course you could write degree equal 5. So if you want to write out the words there. So degree is 5. The leading coefficient here is 4, okay, because that's the coefficient of the highest power term. The way you denote that is usually we put an A, just use that letter, usually by default for coefficients in polynomials. And then you will put a subscript that matches the degree of the term. So you would say A sub 5, because you're trying to indicate the coefficient of the fifth degree term. And so that is 4, right? The constant coefficient here, we usually denote that by a sub 0. In this case, that's 1, right? Because that's the term that doesn't have x in it. So the constant coefficient is 1, just as a reminder of polynomial terminology. All right, now back to the synthetic division, right? So now we want to write down our coefficients, right? So of course the leading coefficient is 4. Notice you're missing, however, x to the 4th power. That's not in the expression. So you give that a coefficient of 0. Think of this polynomial as being 4x to the 5th plus 0 times x to the 4th, right? Plus 10x cubed, right? And then notice again, you're missing a x squared term. So you have to supply that a coefficient of 0, and then a 1 for x to the 1st power term, right? And then your constant coefficient, which is also 1. So this is going to be kind of a long synthetic division, but they all go very quickly, right? Okay, as long as the arithmetic doesn't get too complicated. But the arithmetic is never super complicated because it's only going to be addition and multiplication, right? That's what makes synthetic division nice. So bring down the 4, right? And then minus 2 times 4 is minus 8, add, right? So you have minus 8 again. Minus 2 times minus 8 is plus 16, right? Okay, add, so you get 26. Multiply, minus 2 times 26 is what? Is that minus 52? Right? Add, oh, see, things are getting large here, larger than I thought. So add again, you have minus 52. Minus 2 times minus 52 is a positive 104, right? Okay, add, so this is 105. And then minus 2 times 105 is minus 210. And now we're going to add, and that gives us minus 209. All right, so that was a little bit hairier arithmetic than I had hoped for, but not too bad, right? Okay, this is about as bad as synthetic division will get. Usually don't deal with polynomials with that large a degree. 5th or 6th degree would be probably the highest degree that we would have to really work with practice. So what this tells us is, well, first it tells us that the following, right? If you divide p of x, this polynomial, let me rewrite all of that. If you take that polynomial and divide that by x plus 2, and the reason you write x plus 2 is you always think of your division in synthetic division as x minus whatever number you're doing the synthetic division with, right? Okay, so you think of this as x minus a minus 2, which is the same as x plus 2. So if you take this polynomial and divide it by x plus 2, then your quotient is going to be this, right? All of this will be your quotient, and here is your remainder. So our quotient is, so when we divide here, our quotient is what? 4x to the 4th power minus 8x cubed plus 26x squared minus 52x plus 105. So we get kind of this ugly quotient there, right? And then the remainder is minus 209. So you could write that as the remainder divided by your original divisor, which is x plus 2. So you know this equation is correct. See, by this, you get this quotient and this remainder. But now that's not really what the question was asking. What the question was asking is, what is p of minus 2? So if you took p of minus 2 and plugged it into this polynomial for x, what would you get? And the answer is this remainder, which is minus 209. Okay. By the way, why is that the case? So why is it that p of minus 2 is equal to minus 209? Okay. Well, another way of writing this equation is as follows. If you multiplied everything here by x plus 2, so everything by x plus 2, you would see that 4x to the 5th plus 10x cubed plus x plus 1 is equal to, see if I multiply this by x plus 2, the x plus 2's divide out. And then you get all of this, 4x to the fourth minus 8x cubed plus 26x squared minus 52x plus 105. All of that times x plus 2, and then plus the remainder, which is minus 209. See, if you multiply everything by x plus 2, the x plus 2's will divide out here, the x plus 2's will divide out here, right? And then you get all of this times x plus 2. I'm not going to expand that product. I just want to write it like this, right? So our original polynomial, right, is this quotient times our original divisor and then plus the remainder, right? That's how you always check your long division work, right? When you do a long division, you take your quotient, you multiply it by what you divided by, right? You add on your remainder, and you're supposed to get your original dividend, right? What you divided into. Well, look, now if you plug in minus 2, then if you plug minus 2 in for x here, right? If you plug minus 2 into this expression for x, I'm not sure what I'm going to get on the left-hand side, but look what happens on the right-hand side when you plug minus 2 in for x. I don't know what happens when I plug minus 2 into all of this, but what happens when I plug minus 2 into this factor? What do you get? And you plug minus 2 in for x right here. Yeah, you get 0, right? So you get 0 times this. So all of this goes away. And what do you get left with? Just the minus 209, right? So if you plug minus 2 in for x into this expression, which is the same as plugging minus 2 into this expression because they're equal, you're going to get just this remainder here, which is minus 209. So that's why we know p of minus 2 is the remainder. It's minus 209. Synthetic division gives us a shortcut for evaluating polynomials. Now, you might not think that's a very useful shortcut, but it is a useful shortcut, okay? Because doing synthetic division is much faster than trying to plug the minus 2 into the original polynomial, okay? All right, so the answer to that problem after all of that was minus 209. Let's see, was there another, whoops. Was there another part of this? I don't think so. Let's see if our minus 209 comes out to be correct there, just out of curiosity. I think it's going to be right. Gosh, I hope so. But sometimes I'm wrong. So did it work? Yeah. Okay. All right. So there we have it. Now let's look at problem number 7, where it seems to ask a different question. All right. But it's really the same question. Okay. It's just disguised in a different form. So it says use the factor theorem to show that x minus 1/2, because the c here is 1/2. Use the factor theorem to show that x minus 1/2 is a factor of p of x. So in other words, if you were able to factor 2x cubed plus 7x squared plus 8x minus 6, if you were able to factor that, right, it would turn out that one of the factors would be x minus 1/2, okay? One of the factors would be x minus 1/2. Now, how can we convince ourselves that that is the case? Well, here's what you would do. You would take x minus 1/2 and you would try dividing it into the 2x cubed plus 7x squared plus 8x minus 6, right? You would take this factor, try to divide it into this polynomial, and if it really is a factor, what's the remainder going to turn out to be? 0, right? Okay. So what they're really asking us here is, if I do long division and divide this into this, will I get a remainder of 0? Okay. Well, let's do the long division. But of course, we don't have to do the long division the hard way, right? Okay. We can do the long division how? Using what? Synthetic division, right? Because our what we're dividing by, Emil, our divisor is of the right form. It's of the form x minus a constant. So you can do synthetic division if you're dividing by x minus a constant. Remember, it can't be x squared minus a constant, or it can't be any more complicated than that. So it's got to be x minus a constant. But fortunately, that's often what we're dividing by. Okay. All right. So let's try that. Did y'all write down these coefficients for me? Because we're going to do synthetic division basically just like before, synthetic division using this divisor of 1/2. Okay, let me see if I can find my paper. All right, so there it is. Let's try that. So we're going to do 1/2, right? And we're dividing that into, what were those coefficients then? So yeah, what was it? X cubed what?
7x squared.
3x cubed plus 7x squared, right? So plus a 7, and then was there an x? 8x, right? And then what was the constant there? Minus 6 there? Minus 6, right? Okay. So I didn't leave myself in that room, so let me erase that.
Oh, wait, the first one.
Oh, you said it wrong there. This one is 2. Oh, okay. Oh, that would have messed things up. All right. So first one is 2 here. All right, let me leave myself a little bit of room. So we'll have to write our subtraction line there, or our addition line, I should say, our sum line on the next page. All right, so let's bring down the 2, right? And multiply, and that works out beautifully because 2 times 1/2 is 1. Now add, so you get 8, right? Well, this is an even number, so that works out nicely also. 1/2 times 8 is 4. 8 plus 4 is 12, right? 1/2 times 12 is 6, and you add in, you get 0. Yay! So we have a remainder of 0, just exactly what we want. So it is true that x minus 1/2 is a factor of the original polynomial. See, what that means is that 2x cubed plus 7x squared plus 8x minus 6 is equal to this quotient, which is 2x what? What is that quotient there? 2x to what power? Yeah, 2x squared, right? Because the original polynomial had an x cubed in it, right? The original polynomial had an x cubed in it, but remember, you divided out x minus 1/2. So that means your quotient is going to have x divided out of it, right? So that's 2x squared plus 8x plus 12 times what you divided by, which is x minus 1/2, right? And then plus the remainder of what? 0, right? So see, that sort of becomes superfluous, right? That remainder of 0, you can just ignore that. And so, see, you know it, right? This cubic factors as 2x squared plus 8x plus 12 times x minus 1/2. See, so we got it partially factored there. And then we could try to completely factor it by seeing if we can factor 2x squared plus 8x plus 12. And we have a much better chance of factoring that, right? Because that's only quadratic. See, okay? So we might be able to factor that, and then we would have the original polynomial completely factored. And once you've got it completely factored, then you know all of the zeros or all of the x-intercepts, or also called roots, right, of the original. You would know all of the x-intercepts of the original polynomial. We know one of them now is 1/2, right? Okay. So one of them is 1/2. If we can factor this, then we can know what the other, possibly 2, right? Remember, this was cubic, so it might have had as many as 3 x-intercepts. All right, just as an experiment here, so the problem is answered, right? I think. What are we supposed to put as the answer for this, by the way? Yes or no, or it is or it isn't? Oh, okay, that's kind of anticlimactic, right? Is that it? Yes or no? Oh, it is. Oh, so it is, right? Okay. All right. So so I didn't realize the answer could possibly be no there. Let's go back to the notes here, though, because this is going to come up in other problems. So if you were looking for that original polynomial, if you were looking for all of its x-intercepts, so that original polynomial was 2x cubed plus 7x squared plus 8x minus 6. So if you were looking for its x-intercepts, right, that would be what x values make this expression 0. then you found one of them, you know, is 1/2, not minus 1/2, but 1/2. Okay. In other words, if you evaluate P of 1/2, you are guaranteed to get 0 because this remainder was 0. So 1/2 is an x-intercept. So if you graph 2x cubed plus 7x squared plus 8x minus 6, I don't have a graph of that, but if you graph that, it will cross the x-axis at 1/2 and possibly 2 other places, right? Because the degree is 3. So it may have 2 more x-intercepts. And again, as we already said, we can find those if we can factor the 2x squared plus 8x plus 12. All right, let's try factoring that. Maybe we can factor that easily, maybe not. But let's try factoring that. So let's see, we can factor out what, a 2, is that right? So you can factor out a 2. And so that would give you 2 times x squared plus 4x plus 6, right? Times x minus 1/2. And now we're trying to factor just the x squared plus the 4x plus 6. Ooh, that's not going to be so easy to factor, right? If you try factoring that, you only have a couple of possibilities there. One would be x plus 2 and x plus 3, right? Because you've got to get 2 numbers whose product is 6. So one possibility is 2 and 3. But when you multiply this together, unfortunately, for the middle term, what will you get? Yeah, you get 5x, right? Not 4x. So that's off, right? So, but the only other possibility, Emil, would be x plus 1 times x plus 6. And that's even worse because when you multiply those two parentheses together, you get the 6, all right, of course, but for the middle term you get 7x. So see, that's even worse. Oh, darn it. So this we cannot, unfortunately, we cannot factor that. Okay. Now, however, that doesn't not mean that there's not other x-intercepts. Okay, and this doesn't mean that we cannot find them. All right, because what kind of expression is this, fortunately? Well, it has degree what? Yeah, it has degree 2. Degree 2 is called quadratic, right? So you can try to find the remaining x-intercepts using the quadratic formula, all right, using the quadratic formula. So let's try that. Now, there may not be any other x-intercepts, but let's try using the quadratic formula. If this were degree 3, by the way, we would be out of luck. Okay, it's only because this this factor is degree 2 that we have a chance of using the quadratic formula. Let's see now. According to the quadratic formula, then the other 2 x-intercepts would be what? Minus b, so that's minus 4. The b here is 4, right? Plus or minus the square root of b squared, so 4 squared minus 4 times a is 1. The a here is 1, and the c here is what? 6, right? All over 2 times the a, which is 1. Let's see what happens now to this. Oh, by the way, let me just remind you why you can use the quadratic formula here again. Of course, it's because this is degree 2. Remember, we're looking for the x-intercepts, right? So you're looking where this expression is equal to 0. So you know one place is when x is equal to 1/2, right? The other place would be, again, where x squared plus 4x plus 6 is equal to 0. And that's a quadratic equation, right? So you can solve that using the quadratic formula. Oh, darn it, but things are going to go horribly astray here, right? Because what happens under the square root? We end up with 16 minus what? That looks like 24, doesn't it? Over 2. So you have minus 4 plus or minus, darn it, the square root of 16 minus 24. That's minus 8. And what about the square root of minus 8? Is that a real number? No. Yeah, okay. You cannot have a real number square root of a negative quantity, right? Okay, so not a so this not a real number. So that means that this graph does not cross the x-axis again. It's only x-intercept is at 1/2. All right, so it doesn't have any x-intercepts. Remember, the degree only guarantees you the maximum number of x-intercepts, right? So this one has only not 3. Okay. Now, this I know some of you are probably familiar with this. This issue of taking square roots of negative numbers in situations exactly like this really bothered mathematicians for a long time because they had reasons why they wanted to be able to write down answers to questions like this. Okay, and so they struggled for a long time with square roots of negative numbers, but they eventually came to a resolution of what square roots of negative numbers should be. All right, and they're not real numbers, so they don't exist on the real number line like the x-axis. Those numbers are called imaginary numbers. But that does not mean that they're not valid and authentic numbers. They are numbers. They're just not part of the real number line. Okay, and they have important applications. All right, so but for our purposes, that's a signal that we don't have any more x-intercepts. So the only x-intercept is at 1/2. So when you graph this, don't expect it to cross the x-axis again, right? Okay. Got one x-intercept. All right, let's get back to the, now let's go back there to the homework. Now, I know this kind of question was kind of making you guys crazy, all right, because they're giving you an opportunity to show your work, but they cannot grade this because this is, you know, this is machine graded, right? Okay, so people are wondering, what am I supposed to put in here? And the answer is you really don't have to put anything in there. You might have to type in some characters just to fool it and make it think that you're trying something, but this is not graded. Okay, so I think the only thing that's graded in this problem is the second part here, right? So this is very much what we just did. Okay, this is just kind of repetition of what we did, right? It says show that 5 is a 0, is an x-intercept of the x cubed minus 5x squared minus 6x plus 30, right? So show that you have an x-intercept, and then find the other ones. Okay, so find all the others, of which there may be none. All right, so let's try this. So write down those coefficients for me, and let's see if we can do this. See if I've got enough room here to work. All right, so so to show that 5 is a 0, right, we're going to use synthetic division. Okay, so you're not going to do it the hard way. You're not going to plug 5 into the polynomial and go and grind through the arithmetic and show that the output is 0, right? You're going to use synthetic division to show that the output is 0. What are the coefficients? I think the first one was 1, right? Wasn't that x cubed? Someone has to help me here, right? I got to pay attention long enough to.
Yeah, I wasn't given enough.
Yeah, I wasn't given enough time. Okay. X cubed.
5x.
So minus 5, minus 6 plus 30.
Minus 6x.
Yeah, minus 5x squared minus 6x plus 30. I don't have to write the plus, but there it is, plus 30, right? Okay, so now let's do the synthetic division. So you bring down the 1. Oh, that works out beautifully, right? Because 1 times 5 is 5, so we already got a 0. And then 5 times 0 is 0 again. So put that there, and then we have minus 6. And then 5 times minus 6 is minus 30. So indeed, see, we have a remainder of 0, right? Exactly what we were hoping for. So we know that if you are to factor x cubed minus 5x squared minus 6x plus 30, right, you are going to get what? What's this quotient here? That's 1x what? Squared plus 0x, and then minus 6, so you can skip the 0x, right? Minus 6. So it's so if you factor the original cubic polynomial, you get x squared minus 6 times x minus 5, right? And then you have a remainder of 0. So you can just forget about the remainder of 0. So see, this does factor this way, right? So we know we have 1, 0, 5. Now, to find the remaining zeros, right, we would try to factor x squared minus 6. Well, that's not going to factor too easily. But so we can't factor it, but that doesn't mean we cannot find the remaining zeros. We can just write x squared minus 6 equals 0 and try to solve that equation. That would tell us the remaining zeros. So how do you solve this equation? You can solve this easily because just by inspection. You can write x squared is equal to 6, add 6 to both sides. And if x squared is equal to 6, then obviously what's x equal to? Yeah, square root of 6. But Amanda, remember there are 2 of them. So yeah, there are there's the positive square root of 6 and there's the negative square root of 6. So you get 2 other zeros. Oh, so this original polynomial does cross the x-axis 3 times. Once at 5, but also at positive square root of 6, whatever that number is, somewhere between 2 and 3, right? And then also at minus square root of 6, right? Somewhere between -2 and -3. Your calculator can give you a decent estimate for that, right? So there are your remaining zeros: square root of 6 and minus square root of 6. I think you have to put them in exactly, so don't put in decimal approximation for square root of 6. And again, this part is just kind of meaningless. That was just to give you space to do the synthetic division.
I have a question about I saw there's 2. Does that mean that it's not like one wants to do it twice?
Yeah, that means you'll have to do it twice, right? Okay, so this is 4th degree, so apparently it has it possibly has many x-intercepts, right? 4, and apparently it has 2 for sure, and then they want you to find the other possible 2 if there are any. So let's try doing that then, because we're gonna have to do the synthetic division twice, but you want to do the synthetic division in sequence. So don't do the same synthetic division with don't do synthetic division with the same dividend. Okay, let me show you what I mean. Let me see if I can get my notes here back. Come back, notes, and let's add a little bit of paper. All right, so let's start with the first synthetic division. So what's that first 0 they suggest to you? -2. Darn, I've lost my pen. Let me see if I can. Get that back. We may have to try. Let me try this. All right, so the first factor is, what'd y'all say? Oh, no. We got to write down the polynomial first. See if that helps. There we go. Okay, so what was the divisor? -2, and then the polynomial is, what are the coefficients there? 3 minus 1 minus 21 minus 11, 6. So x to the 4th minus x cubed minus 21x squared minus 11x plus 6. Okay. All right, so now let's start it. Bring down the 3, minus 2 times 3 is minus 6. Add, that's minus 7. Minus 2 times the minus 7 is positive 14. Add, so we get minus 7 again. Minus 2 times minus 7 is positive 14 again. So now we have 3. Minus 2 times 3 is minus 6. Oh, works perfectly right. So there we have remainder of 0. Okay. So, so what you know here is that that original polynomial 3x to the 4th minus x cubed minus 21x squared minus 11x plus 6 is equal to this quotient, which is 3x cubed minus 7x squared minus 7x plus 3 times the x minus a minus 2, which is the same as x plus 2, right? Okay, so you see you've got that original polynomial partially factored, right? Because you have an x plus 2 factored out, but now you got to figure out how to factor all the rest of this, right? The 3x cubed minus 7x squared minus 7x plus 3. But they already told you, another factor should be what? X minus, what's the other suggestion that they gave? You know, recall? 1/3. Okay, so let's try the 1/3. But now you don't have to go back using the original coefficients. Use the coefficients from just your factor. All right, the 3x cubed minus 7x squared minus 7x plus 3. So that's 3 and a minus 7 and a minus 7 and a 3, right? Now you do have to do a little bit of, maybe a little bit of arithmetic here, because you're using 1/3 as your divisor, but let's see what happens. So we bring down the 3, that's not too bad. 3 times 1/3 is 1, right? Minus 6 plus minus 7 plus 1 is minus 6. 1/3 times minus 6 is minus 2. Minus 7 and minus 2 is minus 9. Oh, so it's working out beautifully. 1/3 times minus 9 is minus 3. So again, see, you have remainder of 0. So how does this part, I didn't leave myself enough room, but now you know, how does this part factor? The 3x cubed minus 7x squared minus 7x plus 3, that part factors as what? This quotient, right? Which is 3x squared minus 6x minus 9 times, what was our divisor there? X minus 1/3, right? But don't forget, one of your original factors was x plus 2. So you see how much factoring you've already done there? And you didn't even know it, right? Okay, no trial and error involved. A little bit of cheating, though, because, of course, they told us what factors that use, right? So now we know that 3x to the 4th minus x cubed minus 21x squared minus 11x plus 6, it factors as 3x squared minus 6x minus 9 times x minus 1/3 times x plus 2, right? So we're well on the way to completely factoring it. All we have to do is factor this x squared, this 3x squared minus 6x minus 9. And you know, that's one of the very first things you learn in beginning algebra, right? Is how to factor expressions like this, right? So if you were wondering in beginning algebra, well, why am I factoring? Well, of course, it's to help you solve equations, right? Amongst other things. And that's exactly what we're doing here. We're solving equations because we're looking for the x-intercepts of this original big ugly polynomial, right? Let's see. So how can we factor this if we can factor it? First, you can factor out a 3. So notice, take that out first, because 3 divides into all of these coefficients. So you should factor out constants first. So you get x squared minus 2x minus 3. Don't forget times 3 there, right? Times x minus 1/3 times x plus 2. And then Does that factor? Oh, I think so. So here we don't have to use the quadratic formula because this one actually will factor. I think it factors as x minus 3 times x plus 1. Is that right? Yep, I think that's right. So, wow, that is cool. We got that. Well, we had a little bit of help there, but with that little bit of help, we were able to factor that 4th degree polynomial. Not a trivial task, factoring a 4th degree polynomial. That's not easy. Okay, not easy at all. But there it is factored. So now you know what all 4 of the x-intercepts are. Okay.
How did you mix those two? I see what that first part, and I see what that second part.
I just, after I had found one remainder of 0, right, Amanda? Then I just sort of forgot about the original polynomial and started working with the quotient, right? Because you already know that you can factor out x plus 2. So that's already gone, so to speak, right? And so now you're just worried about this part.
Yes.
That's the polynomial 3x cubed minus 7x squared minus 7x plus 3, right? So I knew I was going to do synthetic division again because they told me 2 zeros, right? So, but I didn't do the synthetic division with the original expression. I did it with this one. Yeah.
Okay, so you start from there.
Yeah, because see, I'd already simplified the problem in a way, right? Okay. I'd already gotten rid of this factor.
Got it.
Yeah. So now I can work with the simplified version, the quotient. In other words, I can work with quotient. So keep that in mind, because if you're looking for multiple factors, once you have found one, then you are now at a simpler problem because you can sort of factor that one out. That's why it's called factoring out, right? You're going to factor that one out and now start working from there, right? Okay, I forgot what I was going to say. Oh, well, Amanda, I'm going to ask you a question here. So now you see why. Now you can see why this 4th degree, the original 4th degree polynomial can only have 4 x-intercepts, because the x, you have to be able to factor this, right, to find the x-intercepts. But a 4th degree, you're only going to be able to factor it what? To get 4 factors, right? Because if you had 5 factors, think about it. If you had another factor here, x, you know, plus or minus something, don't care what it is, right? If there were another factor, when you multiplied all this back together, you would end up with x to what power? See, you have x times x times x times x times x. That's right. You would have too high a degree, right? Okay. So you see a 4th degree polynomial, that's why I can only have 4 x-intercepts, okay? Because when you factor to find the x-intercepts, you can't get more than 4 factors, right? Otherwise, the degree is not going to work. So that's kind of a simplified explanation of what's called the fundamental theorem of algebra. Fundamental theorem of algebra, which I'm getting ready to kind of show you a version of that right now. So, but let's finish. So I think, I don't want to say, oh, all right. So I did want to say something about this problem. Okay, but I have another example like this one. But now we can sort of make a stab at this problem. So it says this one's completely backwards. It shows you a graph, right? Okay, but now it wants you to write down the formula for that graph. Okay, so but it does tell you this graph is the graph of a polynomial. That's important to know that. All right. So, but it certainly looks like it should be the graph of a polynomial, because this is what graphs of polynomials look like. You get these nice smooth curves like this. Okay, smooth unbroken curves, right? And this one has, it looks like what, 3 x-intercepts, right? And they're asking you write down a polynomial of degree 3 that matches this graph. So that sounds plausible, right? This has 3 X-intercepts, so it seems like, you know, we could be able to write down a polynomial of degree 3 that matches this graph. All right, now let's see how we could attempt to do that. Look, the X-intercepts here are what's really important, right? Because what are they? -1, 5, and 6, correct? -1, 5, and 6. So that tells you, here's what that tells you. That tells you that the formula for this polynomial, if you wrote it in factored form, the formula for this polynomial, if you wrote it in factored form, should look like what? Well, yeah, it should look like what? X plus 1, because the first X-intercept was -1, right? And then what? X, what? -5. And then what? X -6, right? Okay. See how easy that is? Is this going to be a 3rd degree polynomial when you multiply all these, which we don't have to do, but if we were to multiply all these parentheses out, would we get a 3rd degree polynomial? I think we would, because as part of that product, you would get what? Eventually, yeah, you would get x cubed, right? Okay, you would get a lot of other terms as well, but you would certainly have x times x times x, which is x cubed. So that's a 3rd degree polynomial, right? Okay, and it's got to have the right X-intercepts, okay? Because, I mean, if you set this to 0 and solve, I mean, the only solutions you can get are -1, 5, and 6, right? Which is exactly the X-intercepts of that graph. However, I've got to caution you, this may not be the right formula, okay? This may not be the right formula. Let me show you why. Because if you look at the graph, what is the Y-intercept here? 30. Okay. Now, that means that we have to check to make sure that when we check the Y-intercept of this formula, we get 30. Okay. Is that what happens? How do you find the Y-intercept of any function, much less a polynomial function? What do? You set x to 0, right? So you evaluate p of 0. So what happens if you evaluate p of 0 here? What do you get? You get 0 plus 1 times 0 minus 5 times 0 minus 6. What happens when you multiply those together? What do you get? 30. Yay. Oh, so that matched. Okay. So the Y-intercept there matches. So I think that's it. There is, I think that's enough. I think that has to be the, so it was easy. Okay. All right. Okay, now let's get finally back to the notes. Let me scroll back up here. So I'm done looking at that homework. So so you should be well equipped now to do that homework. But again, remember, I moved that due date back until Wednesday. Okay, so it's not due tonight. So you still have a couple days to work on it. You still have a chance to answer questions to ask questions on Wednesday. All right. So this is the factor theorem, and so it says just basically what we've already been applying here. If you have a polynomial, it's got to be a polynomial, right? So this doesn't work for other functions, but if you have other types of functions, so if you have a polynomial and you know an X-intercept or a 0 of that polynomial, then that means you know that X minus that X-intercept has to be a factor of the polynomial. Okay, the only X-intercepts you can have for polynomials you get from factoring the polynomial. Okay, all right. So really, the only way to find X-intercepts of a polynomial is to factor. Okay, in a sense. All right. So again, we've already been sort of applying this fact. All right, but this this theorem just sort of states that as a formal fact. Okay. All right. So let's sort of repeat the problem that we just did at the end of the homework. And so now y'all have a good idea of how to do this, right? So find the polynomial of degree 4. We want a polynomial of degree 4, and we want -3, 0, 1, and 5. We want it to be its x-intercepts, its zeros, its roots. Okay. So we want to find a polynomial of degree 4 that has those numbers as its x-intercept. But notice they've got this other little catch thrown in here that P of 2 has to be equal to 10. So they've thrown in a little bit of a curveball here. P of 2, when we find this polynomial formula, P of 2 has to turn out to be 10. That might be the tricky part here in the problem. Okay,